In this video, I'm going to show you how to solve quadratic equations by using the square root method. So notice it says write the equation so that one side is a perfect square and the other is a constant, and take the square root of both sides. So I want to talk about this. The key is that you need one side to be a perfect square, the other side a constant, and then you take the square root of both sides. So if you have x squared equals a number, or some expression squared equals a number, that's what you want, and at that point you take the square root of both sides. So let's talk about this, but let's look at this problem here. X squared equals 81. So our whole strategy when we solve equations has been to get x by itself. So we need to figure out, how do we get rid of the x squared? What's the opposite of squaring a number? And that would be taking a square root. So let's take the square root of both sides, and we would get x equals 9. So there's a problem here, and we need to make an adjustment. And this is something new that we haven't run into with any other type of problem when we're solving equations. Notice negative 9 squared also works. And in fact, with quadratic equations, we're used to getting two answers. And in fact, here we're going to have two answers. And so when we take the square root of both sides, we have to put a little plus and minus in here to indicate that we actually have two answers, a positive case and a negative case. So it's very important that you don't forget the plus or minus, because otherwise you're losing half of your answer. All right, I want to mention another thing here. Notice I wrote for this problem that I just did. Actually, let's look at this number 7. First of all, remember we want to get x squared by itself on one side. So in this case, we need to get rid of the 2. So if we divide each side by 2 here, we get the next line, x squared equals 7. And then I took the square root of both sides. You get, excuse me, plus or minus the square root of 7. Well, just keep in mind that means there's two answers, the square root of 7 and negative square root of 7. Again, sometimes in a college algebra course, you'll be asked to write your answer as a solution set, and so that's what I did here. When I give tests, I don't really care which way you write your answer. Let's look at number 8. So first of all, in this case, I need to get x squared by itself, and I want to get rid of the 9 and the 2. Now, just like with the normal two-step equation, if I have to divide, which here I'm going to need to divide by 2, and I'm going to have to subtract 9, we always do the addition or subtraction first. So let's subtract the 9 on both sides. We get 2x squared equals negative 8. And I'm not quite there yet. I need to divide by 2, and I get x squared equals negative 4. So let's take the square root of both sides. Don't forget your plus or minus. Now the square root of negative 4, I hope that you'll recall, is an imaginary number. We should get 2i out of that. Remember we did this previously. We could write this as the square root of negative 1 times the square root of 4, which is I times 2, or 2i. So that's where we get the plus or minus 2i. So again, I'll go ahead and write this using the set notation, the solution set. Look at number 9. It's very similar to the one we just did, but we don't have x squared. We actually have an expression squared, 2x plus 3. We could actually, because again, we're trying to get to the x, we can get rid of that square, the 2, by taking the square root, doing the opposite. Taking the square root of, oops, I need to put a little 2 in here. Oops. Taking the square root of 2x plus 3 squared, well, you're doing the opposite of squaring, so that's going to undo what you have there, and you end up with 2x plus 3. So in other words, if you have a square, or square something, and then you take the square root, those undo one another. So you end up with 2x plus 3 on the left. Of course, on the right side, you want to take the plus or minus the square root of 36. And so you end up with 2x plus 3 equals plus or minus 6. Now you've got to be careful with these. We want to get x by itself, so this is how we normally do this. Basically here I just subtracted 3 on both sides. Now on the right side, we want to have that plus or minus between our two numbers. So we put the -3 first, and then the plus or minus 6. And then finally, to get that x by itself, we still need to divide by 2. So on this line, I just divided both sides by 2. You get x equals -3 plus 6, plus or minus 6 over 2. So keep in mind, basically you have x equals -3 plus 6 over 2, which is 3 over 2. That's our first answer. And the other answer is x equals -3 minus 6 over 2, and that's where I got the -9/2. All right, let's move down to number 10. So let's take the square root of both sides. Again, it's like the one we just did. Don't forget your plus or minus. So on the left, we're going to have 5x minus 1. And on the right, we've got to remember when we're working with radicals, we need to make sure they're simplified. And 12 has a perfect square factor. Remember, so let's look at the square root of 12. Remember our perfect square factors? 4 was the, other than 1, 4 was the first one that we look at, and that's actually a factor here, so we can break this into the square root of 4 times the square root of 3, which is 2 square roots of 3. So let's go ahead and replace our square root of 12 with plus or minus 2 square roots of 3. So now we'll do the same thing we did on number 9. I need to get rid of that minus 1 because my goal here is trying to get that x by itself. Let's add 1 to both sides. On the left we get 5x, and on the right, again, we have to be careful how we combine these together. Let's put the 1, the positive 1, before the plus or minus. And so we end up with 1 plus or minus 2 square roots of 3, and then we can divide both sides by 5. And so our final answer is 1 plus or minus 2 square roots of 3 over 5. Now you might be tempted to try to add the 1 and the 2 there, but I can't add a 2 square roots of 3 with anything except for another radical 3, something that has a square root of 3 in it. These are not like terms. One's a radical term and the other one's just a constant, the number 1. So this is simplified. Nothing more that we can do. Let's look at number 11. So notice in this one it's a lot like the last two we did, but we need to get rid of that 17. Remember what I said at the top here, we want our expression squared by itself, or in the earlier problems it was just x squared, and we want our everything else on the other side, on the right. So in this case, let's subtract 17 on both sides. We have the square root of, or 4x plus 3 squared equals -16. We're going to take the square root of both sides. So on the left we'll get 4x plus 3. Now remember, the square root of -16 is going to be imaginary. This would be 4i. So let me go ahead and put that in. And so now we're doing like we did before. Let's get rid of the, actually let me rewrite this first. Let's get rid of that 3 by subtracting 3 on both sides. We get 4x on the left. Again, make sure you put that -3 first here between the plus or minus and the 4i. And then let's divide by 4. And so we get x equals -3 plus or minus 4i over 4. Now you might be tempted to cancel the 4's here, but one thing we learn about canceling is we can only cancel products, things that are multiplied. In the numerator you have two terms. You can't cancel a term or part of a term. Now there is actually another way we could write our answer, but this answer is perfectly fine. So let me show you that. We could break this into two fractions, and now the 4 over 4, we can simplify that and we end up with -3/4 plus or minus I. You'll find a lot of times that I'll break the answer into two fractions to simplify it, but in this case we could have stopped with what we had at the top there, or we could break it down the way that I did with the fractions. And that's it for this video.